Hello everyone and welcome to today's video. I'll show you how to handle feedback when working on your designs. The single line you see here is one we finished earlier. I've just added another circuit, which is quite large. It's a 400 amp mode with an 185 square millimeters cable. Usually we copy the cable size from the single line diagram and lock it. But if we do this, the calculation might not be right. That's why feedback matters. We need to pay attention to feedback, understand what it means, and know how to fix it. Let's get started. I've added this circuit, so now I'll run the calculation. When the calculation runs, you'll see a few feedback messages. There's one cross and 3 exclamation marks. What does this mean? For the first one, QF24, a suitable device couldn't be found. This means DOCweb can't find a circuit breaker size for this circuit. So what can we do? Click on the feedback and it will take you to the circuit. Why is this happening? It's because I followed the single line drawing and locked the cable. Now, this cable carries 364 amps. With this installation method, my load is 400 amps, but the cable isn't big enough. To fix this, I should unlock the circuit and run the calculation again to see what cable size is needed. The software suggests using a 300 square millimeter cable. Once I unlock this and run the calculation, the first feedback about the circuit breaker is fixed. Now, there's another feedback for PM1 about the power. The calculated power is 1.143 megavolt amperes, which is for the transformer. In a previous video, I showed how to use the transformer voltage regulator to fix a high voltage drop. This feedback means the transformer is too small for your loads. There are a few ways to fix this. If you can increase the transformer size, just unlock it and run the calculation. The software will show you what size you need. If that's already set, then we need to look at your loading. In most single-line drawings, there's a diversity factor for each load. For example, if I click on this bus bar, it's set at a loading factor of 100%. But in reality, it won't be at 100% all the time. Even if you look at IEC 61439, the standard for switchboards, it states that with a certain number of outgoing circuits, a demand load factor can be used. Let's say we set this load factor to 80%, or 0.8. If we change the loading factor to 0.8 and run the calculation, what happens? This feedback is now cleared. This means you don't need to change the transformer size, and all your loads are normal. We can use a loading factor of 80% here, which is fine. The diversity factor is actually the same thing. There are a couple of ways to solve this kind of feedback. It's important to understand what these feedback messages mean and how to solve them. These 2 or 3 feedbacks are common, along with things like voltage drop. As I mentioned earlier, you can use the transformer regulator to fix the voltage drop. Another way is to increase the size of the cable. This makes the cable bigger and helps remove voltage drop, so keep these types of feedback in mind and how you can solve them. I hope today's video has been helpful for you. Feel free to join us for other videos where we'll dive deeper into more topics. Thank you so much and have a good day.